Hey guys, good morning. Welcome to the Aerospace Structure series. We are going to continue the last topic as fatigue strength and analysis. Last two classes we have seen the fatigue fracture and the fatigue loading. Now we are going to see the fatigue fracture surfaces. Once the fatigue is happened, a fracture is happening, how the surface looks like, what are the treatments they have done that we will see. The fatigue fracture surface having the two things. One is macroscopic features and microscopic features. Let's first we'll see the macroscopic features. The region of the macroscopic fatigue fracture surfaces. One is first region. The region having a beach mark, that is a clamshell mark, where crack growth rate is relatively slow. That is called the mark region, beach region. It is a series of uh, concentric of moon-shaped lines. They can also be nearly straight and the parallel. These lines indicates where the crack formed actually stopped in this process. The crack does not start again until the loads, which initiated the crack in the first place, is applied again. If the load is removed, then the crack stopped and a new mark is made where we can know the crack growth direction and location of all the initial cracks were beach marks. So macroscopic features, the rotation direction of this broken axle house can be examined by beach mark. It is because crack tends to grow rapidly in the opposite direction in general. The below figure shows the fatigue fracture surface of axle housing. Four sources of fatigue cracks can be found at each beach marks located around the fatigue crack growth source, and the final fracture occur at the top. Second region in the macroscopic features, the region the crack grows relatively quick. This area is more rough and irregular than the first region because the amplitude of the load increased due to the reduction of the loaded area. The first region is dark than the second region. It is because the first region exposes to the large air longer than the second region. Third region, the region of final fracture. The final fracture can be brittle or ductile fracture, depends on the material property and environmental condition. If the final fracture occurs in a brittle manner, that is a cleavage edge form, the fracture surface is smooth and bright. If the final fracture region is large, it means the amplitude of the loading is large. If the final fracture region is small, it means the amplitude load is small. In a macroscopic final fracture location, the loading, the size and the location of the final fracture region depends on the size of the loads. Normally, the local location of the final fracture region is located on the center where the load is large, and it moves from the center to the outer as it slow becomes load is low. It is because the fracture occurs at one weak spot where the load is low. The crack initiates and propagates at the spot and leads to the final fracture. The sharpness of the notches also affect the location of the fracture surface. The macroscopic features occurs at the applied to loads and notches. Let us take smooth, mild, and sharp notches. These are the wave format and the second region and third region failure sample visual affecting factors and microscopic axophatic surfaces. Microscopic feature, the fracture by the tensile load without notch. Let us take the one more example, whereas the crack configuration of the metal without notch under the torsional load. If the crack occurs and the propagate due to the low shear stress, there is no clear features of the fracture surface in the general. If the crack propagates due to the tensile stress, in case only tension loads is applied to the shaft, it is easier to find some features of the fracture surface. Crack configuration of the metal without notch under tension. Crack propagates due to the maximum stress, that is perpendicular to the axis of the shaft. Cracks propagate due to the maximum stress, that are perpendicular to or parallel to the axis of the shaft. Cracks propagate on the surface of the maximum principal stress. In this case, tensile stress is dominant. The crack initiates on surface maximum stress that is parallel to the axis of the shaft. After the crack propagate on the surface of the maximum principal stress occurs. This is the width notch, high loading and low loading pattern, which shows the cracks configuration of the metal with the notch under the tensile load. Macroscopic level we are seeing now. We are moving to the microscopic level. Before that, we see the fish eye. Fatigue fracture typically occurs on the surface of the metal, but also it occurs in inner part of the metal causes the hardening and of the surface of the material. In this case, white small rounded shapes is occur on the fatigue fracture surface. It is called fish eye crack propagation from inclusion. Microscopic level striation. Microscopic fine strips are found by scanning electron microscopy of the fatigue fracture surface. Serration indicates the location of the crack formed and they are perpendicular to the direction of the crack growth. The interval of the two serration is same with the periodic of the cyclic load, that is the one cycle per growth speed. When the serration is observed on the fracture surface, it means that the fracture is caused by the fatigue and the growing speed of the fatigue fracture crosses by the can be calculated using the serration intervals. So next the microscopic feature, that is ductal striation. Ductal striation is something called plastic striation and it is relatively clear because it has relatively large plastic deformation. In general, ductal striation is built up of on the surface that is perpendicular to the surface of the maximum tensile stress. So here we can see the seven striation in each stripes. Ductal stress striation for the aluminum 2024 P3. This is a 10 striation. Next one is platelet. Ductile striation is made up of long strip shapes region along the direction of crack propagation. This region is called platelet. This striation shows upon the crack growth rate is fast. The interval of the striation observed on the fatigue fracture surface from 0.1 micrometer micro to the several micro in general. The crack growth rate per cycle dA by dN about 2.6 cycles per second or the cyclic loads per cycle. T6 titanium 6 aluminum vanadium 4 vanadium platinum. We can see the picture. Brittleness striation. Brittleness striation is found easily when the crack growth is corrosive to the environment. Fatigue fracture surface shows very flat in this region. Brittle striation aluminum 7075 T6 aluminum. So these are the few microscopic level observation from the fatigue failure materials formed of striations and the plates. So we'll see you on next class. Thank you.